Good morning, everyone. In today's data driven organizations, data has become one of the most critical assets for decision making, analytics, and operational intelligence. However, maintaining the quality and reliability of data across complex data pipelines remains a significant challenge. Large enterprise systems process massive volume of data coming from multiple sources. During this process, issues such as missing values, duplicate record, inconsistency formats, and invalid entries frequently occurs. Without proper monitoring and validation mechanisms, these issues propagate through the data pipelines and eventually impact the business intelligence dashboards, machine learning models, and operational systems. To address this challenge, we developed py-QLense, a unified platform designed to continuously monitor, validate, and analyze enterprise data quality using automated rule execution and real-time monitoring dashboards. Before we move towards the py-QLense platform interface with its monitoring dashboard and visual analytics, it's important to first understand the core engine that powers the entire system behind the scenes. At the heart of py-QLense lies the data quality rule execution engine, which is implemented through a set of 11 SQL scripts. These scripts are not simply supporting queries, they form the actual backend processing engine of py-QLense, responsible for executing and orchestrating the complete data quality validation workflow. Each script plays a specific role within the data quality pipeline, including executing validation rules, calculating rule level metrics, aggregating validation results, orchestrating incremental and full scan executions, and storing the final results into dedicated data quality metric tables. Together, these 11 SQL scripts operate as a coordinated validation framework, enabling py-QLense to perform large-scale data quality checks efficiently across enterprise datasets. Once the engine completes execution, all validation results are stored in structured metric tables, which are then consumed by the py-QLense platform to power its monitoring and analytics capabilities. Now that we have understood the backend engine of py-QLense, let's move to the platform interface where all these validation results are visualized. After logging into the platform via the Snowflake credentials, we land on the main dashboard, where we have several datasets that lies into our Snowflake account. Here we can see the overall data quality percentage for today, which represent the aggregated outcome for all the validation rules executed by the py-QLense engine. The data quality score is calculated using the average weighted formulas. Our platform support two types of validation scans. The first one is incremental data quality scan, which validates newly ingested data in the pipeline, and the second one is the full data quality scan, which evaluates the entire datasets. This scanning capabilities allows organizations to monitor both real-time pipeline updates and complete dataset validation, ensuring continuous visibility into the health of their data. Also, we can easily monitor today's scan activity and total number of scans that we have implemented. Next, we move to the table level monitoring sections. This view is providing an overview of data quality metrics across this particular table. For the table, the platform displays the number of total records, today's loaded records, today's scan record, the quality score, data quality, and the different types of checks that we have implemented on this table. Like completeness is showing the score, uniqueness is showing 100%, validity is showing particular score. Also, the quality score history, as we have scanned this table for particular day only, so it is showing for the particular day. And volume shift detected is the recent anomaly detected for this particular tables. This allows the data engineers and governance teams to quickly identify which tables are performing well and which one requires the investigations. If a particular table shows a lower data quality scores, users can drill down further to identify the root causes as well. Next, we move toward the history tab. The history tab is overall shows each and every scan that we have implemented on this particular table. As we have implemented the full scan throughout the datasets, it shows full scan. We have implemented profiling on this table, it shows the profiling in this particular. Here we can easily schedule particular scans on these tables. Then we move toward the column level drill down. To investigate issues more deeply, the platform provides a column level drill down view. Here we can analyze the data quality of each individual column within the tables. Like this particular column is showing 70% data quality and column health, so it needs the attention. Like we have implemented the active checks, it's completeness checks. It's showing a medium types of scores like completeness check, uniqueness checks, the type of the data, total rows loaded, distinct values and null counts within that particular tables. The null value detection, duplicate value detection, format validation, domain validation, and rule compliances. This granular visibility enables user to quickly identify exactly where data quality issues originate. Column level insights are particularly important in enterprise environment where maintaining accurate and consistent data is critical. Then we move towards the health tab. The health tab is an AI-driven observability matrix. This AI-driven observability matrix where we are providing the data schema, the data quality, and the rules, fail checks, pass checks of the particular datasets. So after giving this to particular AI model, it providing and real and recent insights like the banking account data layer has experienced a decline in reliability. This happens because the data quality that degrades due to our particular table level and column level metrics have some anomalies detected. So here the freshness, volume, schema, health score, all the metrics that are useful for the observability that we are being shown here. Also the impact and lineage also being pointed for the particular table at some points. Then we move towards the rule tab. This tab provides a detailed information about the validation rules configured within the system. Each rule represented a specific validation check applied either at the table level or the column level. The platform display rule definition, execution metrics, implementation details, and rule pass and failure results. The rule-based framework allows organizations to systematically implement and manage their data governance and data quality policies. Then we move towards the alert and anomaly detection. The alert module is responsible for detecting the anomalies in the data quality metrics. If there are sudden spikes or drops in quality scores, the system identifies as anomalies. This alert helps detect issues such as pipeline failure, unexpected schema changes, or sudden increases in the invalid data. By detecting these anomalies, early organizations can prevent poor data quality from propagating across downstream data. Then we move toward the data preview sections. The data tab allows users to view sample records directly from the datasets. This feature enables engineers and analysts to quickly inspect the data, analyze potential issues without switching to external tools. Then we move towards the failure analysis. The failure section highlights validation failure detected by the system. Here we can see total failed checks, number of failed records, and the most critical rules that failed within the system. This information helps teams prioritize and resolve the most important data quality issues that occurred first. At the top of the platform, we also provide controls for managing validation scans. User can trigger full scans, configure database executions, or schedule automatic scans for the particular tables or column level as well. This ensures the data quality monitoring happens continuously without requiring manual interventions as well. The run module. Finally, we move towards the run module, which provide advanced operational capabilities. The scan feature allows user to execute custom scans on the specific tables or the particular column level lineage as well. Then the profile feature automatically analyzes a dataset and suggests possible validation rules based on the data structures and the characteristics. And the OpenSQL editor allows data engineer to execute lightweight queries directly within the platform for quick analysis and debugging. So, to validate the performance of py-QLense, we conducted a testing scenarios using banking dataset. For this demonstration, we implemented a Medallion architecture pipelines and loaded approximately 1.3 million records into the system. Across the datasets, we configured 141 validation rules. When the py-QLense engine executes these rules, each rule evaluates multiple records across the datasets. As a result, the platform performs nearly 10 million individual data quality checks during the execution. Despite this large validation workload, the entire process completed in approximately 1 minute and 24 seconds, consumes only 0.00060 Snowflake credits. This demonstrates the efficiency and scalability of the py-QLense rule execution engine. In many traditional data quality platforms, executing millions of validation checks often involves multiple workflow layers, orchestration pipelines, and external processing system. This approach can introduce significant processing overhead and increase execution time. In contrast, py-QLense performs validation directly inside the Snowflake environment using optimized SQL execution by minimizing the data movement and leveraging warehouse compute resources efficiently. py-QLense can maintaining extremely low compute cost. This architecture makes py-QLense highly scalable for enterprise-level data ecosystem. To conclude, py-QLense provides an end-to-end solution for enterprise data quality monitoring. With a powerful backend validation engine and intuitive monitoring platform, organizations can detect data issues early, maintain reliable datasets, and ensure trustworthy analytics. By combining automated rule executions, monitoring dashboards, anomaly detection, and flexible scan capabilities, py-QLense enable organizations to maintain high standards of data quality across their entire data ecosystem. Thank you everyone.